All right, we're back from lunch. And if you want to put in the chat what you had for lunch, that would be great. So let me know you're back and ready to roll for our afternoon session of Boot Camp 2 Virtual. I do want to go over my challenging poll question, and I was trying to be sneaky with my question. Job approval authority is a quality assurance process used to ensure select all that apply. And if you were confused, I understand because I tried to make it hard and I intended it to be that no answer was correct. But I realized when doing the poll just before lunch that it forces you to answer at least one. So that's on me. I apologize. But just to go through the question or the options there, employees are compensated according to the work they perform. That's not the case. I wish it was the case. I wish people were paid based on the complex work that gets done, but compensation is not tied to job approval in any way. The second option there, work can be completed outside of NRCS standards and specs if practical and cost can be saved. Not true. Under job approval, everything has to fall within NRCS standards and specs, even if it seems to make sense, and even if cost could be saved. You still have to meet standards and specs. Standards and specs are developed at the national level, and then they're made state specific by state discipline leads. But they are vetted and worked over and fretted over and reviewed and approved by many people at many levels, including the Pennsylvania State General Committee. So lots of people have input into those, and they're developed by people much smarter and more experienced than me. So they do have reasons for the requirements that are in them. The next one, which is the closest answer, and which is the one that I picked, engineering practices are always designed and inspected by competent staff. And that answer wouldn't have been correct because you don't need to have job approval to design or inspect. You need job approval to approve a design or certify a completed project. But that one was probably the closest and hence the highest percentage there. And then finally, professional engineers are never needed to get work completed. Well, nobody got that one wrong. We know that the case because you have to have a PE's signing off on liquid storage tanks. So that's the poll. Thanks for participating. And with that, we are, what do people have for lunch? Grilled cheese, granola bar. I had bean soup. That's great. Our next presenter is going to be Peter Hoagland, you've all heard some forestry concepts from Peter at Bootcamp 1. He's going to take it to the next level. These are advanced forestry concepts at Bootcamp 2. So Peter, our NRCS State Forester, take us away.
All right, thanks, Tim. If you guys are confused, he's Tim Peters. I'm Peter Hoagland. We're different people. We often get each other's emails. So here is, if you guys can see my screen, give me a thumbs up. All right, great. So we are going to jump into advanced forestry concepts. These guys had a problem with me calling it overview for every presentation. So now it's advanced. And so we're going to talk about some current Pennsylvania forest conditions, silvicultural systems, and we're going to dive a little bit deeper into one of our bread and butter practices, the forest stand improvement conservation practice, and talk about some treatment methods with that. So I think we kind of discussed this at Basic Boot Camp a little bit, but throughout Pennsylvania, there's this kind of typical systemic forest problem, which I'm calling inadequate structure and composition, which is one of our resource concerns. And this is due to the fact that Pennsylvania's forests have inadequate regeneration to sustain our future forests. So our forests are now primarily even-aged due to that past mismanagement or past management in some cases. And that leads to insufficient diversity of age class. Size class diversity too. So if you look at this chart, we have the least acreage in these newer age classes, which is kind of a problem for our future forests. And that's due to a lot of changing ecological patterns now. We're seeing changes in disturbance regimes that have shaped our current forests. Those disturbance regimes have changed in type of disturbance regime, frequency of disturbance regime, scale and distribution. And there's now some new disturbance regimes in our forests that we really historically did not see. We've seen for the last 100 years or so a lot of fire absence in our forests, significant browsing. I'm calling it chronic browsing by deer. We're seeing a lot of canopy disturbances. Ooh, I called it gypsy moth. It's no longer called gypsy moth. It's called spongy moth. I should change that one. And we got a ton of invasive pests. There's some cool acronyms on your screen there. EAB, emerald ash borer, CSSM, cherry scallop shell moth, HWA, hemlock woolly adelgid, just to name a few. And we have a ton of invasive plant competition, as well as unsustainable forest harvesting. These are kind of our new disturbance regimes, and that's changing our forests. In Pennsylvania, there has also been, we touched on it briefly in the previous slide, there's been significant impact on forested ecosystems by human disturbances. This has included road building and logging and agriculture, introduction of those non-native invasive plant species, and specifically fire suppression. So we can look back pretty far back. This tree ring goes back to 1652 at the center. And so through the study of dendrology or dendrochronology, scientists have proven that ecosystems in Pennsylvania did see frequent fire disturbance, and that did shape the structure and composition of vegetation in those ecosystems. But since modern forest fire control policies started in the early 1900s, we've drastically shaped how often fire is seen in our modern ecosystems. So this tree ring that I'm showing here is a sample of a red pine from the northern tier of Pennsylvania. It's a sample, and many other studies have shown something similar, shown that fire was frequent across our landscapes. So the mean annual fire return interval prior to European settlement was about every 13 years, meaning that on average in the eastern U.S., our ecosystems saw fire more frequently than they saw cicadas. But since the early 1900s, people started suppressing fires. And that means that the mean fire return interval jumped to about 46 years from 13 years in the eastern United States. Then other studies have shown that fire return interval is more drastic, up to it was every 4 to 6 years. Now it's greater than 50 years. So this is all tied in and supported by a really successful marketing campaign, one of the most successful in history, with Smokey Bear telling us that the fires in the forest are bad. And you know, messages have changed a little bit since this one, but we know that that fires shaped our forest. So we can look back a long ways with this dendrochronology and see how often there was fire on the landscape. And when there was significant absence of fire, either due to, shown on this chart, due to the beaver wars and European disease, and then, you know, when we started suppressing fires in the early 1900s. If you take a look at this chart, every black vertical dash was a fire. And that's really no longer the case anymore. And this is from north central Pennsylvania. So our forests are really transitioning. They're transitioning in species composition to shade-tolerant species. We're going to talk about shade tolerance a little bit. Oak species are declining. Non-native invasive plant species are certainly increasing in their coverage. And that all kind of equates to a lack of adequate regeneration. When I'm talking about the word regeneration, that's the new trees out there. That's the baby trees that are the future forest, and they're really not out there. So the data is showing, and this is from the U.S. Forest Service, showing that large diameter stands have steadily increased since the 1950s, while small diameter stands the smaller forests, smaller trees, making up basically younger successional forests are decreasing. And there's a lot of factors at play, including that absence of fire in our forests. But what we can also see from this data is that forest types dominated by oak species have even lower percentages of small diameter stands compared to some of the other types. So if you look on the chart on the right side, if you look at the northern red oaks, the chestnut oak, the black oak, those types, they have less than 1% of their area in small diameter stands. Whereas cherry, white ash, yellow poplar, granted ash has kind of fallen out, but those forest types have up to 10% of their area in small diameter stands. So there's a big difference there just with the type of forest. So that lack of small diameter stands in Pennsylvania oak forests really illustrates that difficulty that we have in regenerating oak forest types in Pennsylvania. And so where are those oak forest types typically found? Well, this is U.S. Forest Service forest type group map. The orange is our oak and hickory forest, and the yellow is our maple beech birch forest. So this is, essentially the bottom 2/3 of the state is oak hickory forests. And this graph illustrates what we just saw in the map previously. This equates to about 9 million acres of oak hickory forest statewide. But these oak dominated forests are certainly not the same as they were in the past before modern fire suppression and many other impacts like the invasive plant species that we're seeing today. These dominated forests look a little bit different now, and we mentioned that. What we have now is a dense forest with very less age class and structural diversity than what was probably previously out there. When we look at it from an overall viewpoint, it can look really picturesque like this, to the untrained eye, of course. But when you take a look with a typical oak forest, you see something that has a closed canopy due to the extended absence of fire and other stressors. So it is really difficult to regenerate oaks in conditions like this because they tend to be intolerant of shaded conditions, the species do. So compare that to species like red maple that are very tolerant of shaded conditions, and you can see some of the previous charts. You can see why some of those previous charts show very little oak regeneration with that dense understory shaded conditions. So this change over time in less fire, what's called less fire importance on our landscape includes the lack of fire frequency and severity. And this term for this change is called mesification, which means essentially the development of cool, moist understory conditions in our forest and the increased presence of less flammable fuel beds in oak and pine ecosystems in the eastern United States. So if you look in the trees, kind of the tree charts in the beginning, in the middle of your screen there, in this chart, the olive green trees represent oaks, and the dark green trees represent pines, and the teal trees represent mesophytic species, like maples. So we're getting an increase of those maple and other species that are less fire dependent, less flammable than the oak species or the hickory species that were typical in our historic forests. So I also want to note that this mesification of our forests due to fire exclusion and suppression has also had an impact on wildlife species that utilize our forests. So the State Wildlife Action Plan notes that for birds, especially for birds, mesification has played the role played partial role in the decline of some wildlife species. This is not the only contributing factor for for species listed as greatest conservation need. But it is evident that when combined with other impacts like invasive species, there is a great need for habitat improvement, which is also good for creating healthy and resilient forests. So that lack of landscape variability and the lack of early successional habitat has had a significant impact on species like the golden wing warbler that relies on a habitat type of early successional forests during early fledgling. So if you haven't heard about the golden wing warbler, it's kind of one of our focal species. It's a neotropical migratory songbird. It winters in portions of Central and South America, and it breeds in Central and Southern Appalachian Mountains, including in Pennsylvania. So this is a species that really does require early successional habitat for early fledgling, and that's really largely lacking due to the lack of disturbance in our forests. So this species has declined by an estimated 97% since the first breeding bird survey in 1966 in the Appalachian Mountains range. So in that background picture here, you can show, it shows a landscape in the Poconos where we've seen some landscape scale variability in forest structure and composition due to projects being implemented. So in areas like this, we are seeing monitoring evidence showing golden wing warbler usage in these areas, but it's not enough to just create early successional habitat. It's also necessary to have nearby variability in different stages of succession. So throughout the state, this is kind of our focal area for golden wing warbler projects, and that's based on the data. We have golden wing warbler priority areas based on where species occurrences have been seen, and then we have an overall geographic golden wing warbler project boundary. And that's because we know that different wildlife species utilize different stages of the forest. I would not expect you to pick out specific species from these shadow images, but look under the pole shrub to pole timber section right there in the middle, in kind of the green. We see a couple other species that are also in decline, like American woodcock. We also see the ruffed grouse in there. And if you take a look at the high to low shrub stage, we can see that this is where some of our pollinators are also in decline. And there's other factors at play here for these species, but habitat loss is a major contributing factor. But for example, with the ruffed grouse, we know that West Nile virus is also contributing to population declines too. So we can compare what we have now to what was typically described by early European settlers as something that probably looked a little bit more like this, with more of an open canopy, more understory diversity. Today, we would probably categorize this as an open oak woodland. And conditions like this really do allow for light to get to the forest floor and increase production of seedlings to get established from oak acorns, but it also provides good conditions that are good for understory grasses and forbs. But it's not as simple as reintroducing fire into an ecosystem. There can be a systems approach, like we talked about with other land uses, to get to a restored open oak woodland condition like this. So you might say, forests just grow on their own, right? And you might be right, but yes and no. They will grow on their own into degraded stands composed of less desirable species. Think of that mesification chart that we were showing, with a lot of invasive species, with competing native vegetation and a lot of low shade. If you see a forest like this, with this picture right here with a lot of hay-scented fern and one oak popping through, this is often equated to as a lollipop sticking up for the deer. That thing's going to get munched off because the deer are not going to eat the hay-scented fern. They will eat the oaks. So what can we do? Well, forest management. We can correct the conditions. We can implement proper and sustainable forest management that can have a beneficial impact on our forests. It can create resilient forests, resilient to changes in climate, insects and pests, diseases, also natural disturbances. That can alter the species diversity, the age class diversity, alters the composition, the density, the structure, and the function. And that's all based on data collected and planning out the desired future condition of the forest. That is done through silviculture. So it's way more than just managing for a client's timber out there. Silviculture is it's the practice of controlling the establishment, the growth, the composition, the health, the quality of the forest to meet the diverse needs of the client. So it can include wildlife habitat, it can include water quality, it can include forest health. So that is combined into conservation planning and really done through a forest management plan. So key to silviculture is shade tolerance. And shade tolerance is the relative capacity of a tree species to compete for survival under shaded conditions. So different trees have different levels of shade tolerance. But it's key to know that often the most limiting factor for tree growth in the eastern US forests is sunlight. So shade tolerance is tied directly in with the silvicultural methods that are used to harvest and to regenerate a forested stand. So it's divided generally into tolerant, intolerant, and intermediate categories. Here's a chart that highlights shade tolerance levels for trees typically found in Pennsylvania's northern hardwood and oak hickory forests. So you'll notice that some species are very tolerant of shaded conditions like sugar maple. Some species are very intolerant of shaded conditions like quaking aspen. So if you were trying to regenerate an aspen forest in a forest currently dominated by, maples, you would most likely need to remove all of the shade, which plays into what silvicultural treatment you would be selecting or the forester would be selecting in the forest management plan. So those intolerant species usually are the first to grow on the early pioneers after a natural or a human introduced disturbance. That usually opens up the canopy a lot. So these are called pioneer species. They tend to be relatively short-lived, fast-growing, have light seeds. So this can include species like quaking aspen, black locust, white pine. Obviously, that's a much longer growing species. Tolerant species, these trees are normally not the first to colonize open areas. Instead, they grow up into an existing canopy. They tend to live a much longer time. They grow slowly. They have heavier seeds. So this can include species like sugar maple, hemlock, and beech. And then intermediate species have characteristics that are kind of in between the tolerant and the intolerant species. Seedlings might not reach the sapling or the pole size unless there's gaps created in the canopy, either through disturbance or through management. So oaks and hickories usually fall into that intermediate category in Pennsylvania. So as a conservation planner, you will likely be in a situation where you're asked to go out to a landowner's forested property. So this slide and the next few slides, I'm going to give you kind of an indication of what to keep an eye out for in the forest. In the understory, at the ground level, that's called the understory, you're going to want to look out for the presence or the absence of tree seedlings. Like in the bottom left there, you see some chestnut oak seedlings. That's referred to as regeneration. You'll also want to look out for presence of invasive species like this autumn olive that you see in the bottom right. You can also look out for the impacts of deer. Deer have a huge impact on our forests. So you can look for signs of high deer impact. This can have if you do have heavy deer browse pressure, you will likely not see many tree seedlings, like this forest on the left, that's dominated by hay-scented fern. Or if you do see seedlings, they might be disfigured without a central leader due to repeated browsing, like the example in the bottom there. Another telltale sign of heavy deer browse impact is a browse line, like you see in the picture on the right, just behind the deer. And so this is where the deer have pretty much eaten everything that they can reach. If you are fortunate enough to see seedlings in the understory, you may want to pay attention to the fact that to the type of seedlings that you're observing. Maybe you're seeing oaks. Maybe you're seeing only maples. This is a good consideration when you're comparing to what tree species are found in the overstory or the upper canopy levels of the forest. So if that overstory has oak trees and the understory is only maple trees, that's going to give you an indication of what the future forest is if the landowner were to remove the overstory trees without any additional management considerations. And speaking of the overstory, you want to take a look at what the species diversity is in the overstory. You don't need to know all the tree species, but it is helpful to understand what you're looking at if you're looking at a monoculture of only one species, like this pine plantation, or if you're looking at a forest that's diverse and has a representation of many native tree species. In the overstory, you'll want to look and see if there is representation of native species in both the overstory and the midstory. Midstory is kind of in between the ground level and the canopy level. So pay attention to gaps in the canopy and see if there's light reaching the forest floor, or if there are undesirable or noxious invasive plants that are interfering with the growth of desirable plants. That could be tree of heaven in the overstory. That could be sweet birch in the understory that creates kind of a dense understory shade condition that's limiting the growth of more desirable seedlings like oaks. And when you're looking at the invasive species, you'll want to look for what type of species there are. Like if you're dealing with herbaceous species or woody species, brush species, you'll also want to estimate how widespread that infestation is throughout the forest. The thresholds that we've built into the Wildlife Habitat Evaluation Guide, or WEG, are broken out into three categories: less than 10% coverage, 10 to 35%, or greater than 35% coverage of those invasive plant species. And speaking of wildlife, you want to look for those seed sources, if there's a diversity of seed sources. These are referred to as mast, M-A-S-T, mast sources, and it's preferable to have a diversity of at least 5 different seed sources. That can be hard mast, like acorns or hickory nuts, or that can be soft mast, like fruits from black cherry. Another thing to look out for is wildlife features. They can be tall standing dead trees, which are called snags, or there can be cavity trees that have holes or injuries in them that can be used for wildlife, such as nesting holes. We'd also want to see at least 8 of these snags or cavity trees per acre. Those can be substituted with other wildlife features like brush piles or even nesting boxes to provide habitat for specific species. All right, now I'm going to transition into what you will not be doing out in the field, but it's really important to understand the different categories of silvicultural systems. You will, unless you're a forester, unless you're a forester, you're not going to be prescribing silvicultural systems or treatments. That's planned through a silvicultural system through the forest management plan. But what I'm going to be describing here are the silvicultural systems for your understanding of what you might see found in a forest management plan written by a forester. So there are generally two broad categories of silvicultural systems that you need to know, and those are even age management and uneven age management. So the category names are based on the end result, not the current status. So, for example, an uneven age stand could have an even age silvicultural system applied. So I get that's a little confusing, but we're going to go into that a little bit more detailed. So if you apply an even age silvicultural system to a stand that is currently uneven aged, it might end up looking like a clear cut like this in our picture here. All right, but first I'm going to start with even age management, and this is referred to as a planned sequence of treatments designed to maintain and regenerate a stand with one age class. So the intended goal of managing will be an outcome of an even age system. And that is, it's important to distinguish from our current forests that are largely even age due to past management, but that doesn't mean that you need to choose an even age silvicultural system or a forester. Even age systems are often used for plantation systems, like when managing species and for when managing species that are extremely intolerant of shaded conditions. But there are also even age systems that get utilized quite a bit in Pennsylvania, like seed tree systems or shelterwood systems. So a seed tree system, this chart shows what the canopy of a seed tree cut would look like. It's retained after the harvest. So the residual trees, the trees that remain, are very scattered, and they're trees that have the best genetics on the site, which will provide seed sources to be dispersed throughout the site. The seed trees can be susceptible to wind-blown damage. Specifically, the site is on a ridge top, so that's a huge consideration when doing a seed tree system. So seed tree focuses on leaving those seed trees that are the best desired species type and demonstrate the best genetic components. We want to leave behind dominant non-forked trees. It's a reforestation method that uses mature and desirable trees from the existing stand to provide seed for the new stand. And the seed trees are typically eventually removed after regeneration is established, but they can be retained for wildlife or visual quality objectives or other objectives. So seed dispersal can be really species dependent. So not all trees are equal in spreading their seeds. Some of them with heavier seeds will simply just drop straight down and may be scattered by wildlife. Some of them with lighter seeds will disperse much more widely. Clear cut is a silvicultural system that removes all the trees from a site. It allows it favors species that are intolerant of shaded conditions. So a clear cut might be prescribed by a forester as a clear cut with reserves that leaves behind a few trees, such as those necessary for wildlife habitat components. But it does get a pretty big negative connotation because of concerns over soil erosion and elevated water temperatures and the potential for loss of wildlife habitat and to be honest, mostly aesthetics. But the fact is that it's a legitimate silvicultural system when it's used to regenerate an even-aged forest, and depending on what species you're trying to regenerate. It might also be essential to providing early successional habitat, but keep in mind that that many other species require early successional habitat that are also declining and require a diversity of age classes too. So it's helpful to incorporate nesting and perching sites. This might mean that management doesn't focus solely on even age management. In some cases, it might have more of a wildlife focus. Last even age management focus that I want to concentrate on is a shelterwood cut. It allows even age stands to regenerate beneath the shade of mature trees from the previous stand. So essentially, it's harvesting in stages, and those mature trees can be removed when the regeneration is sufficient in height. This is something that we do quite a bit in Pennsylvania as a shelterwood system, especially for golden wing warbler habitat. A shelterwood system is typically more patchy than a cut used for a seed tree cut, and it focuses on retaining species of trees that continue to be desirable on the site, as well as those that will provide a quality seed source. Most typical treatment that we're using for early successional habitat development in Pennsylvania, specifically for golden wing warbler, but for other species too. And so this is the typical sequence of treatments. Include 2 or 3 distinct types of cuttings. There's an optional preparatory cut. Usually, we're treating invasive species before we even get to that point. There's an establishment cut that prepares the seed bed, provides seed for the new stand, and then a removal cut, the overstory removal, that releases the established seedlings and saplings from competition with the overstory. All right, transition now to uneven age management. So uneven age management focuses on regenerating shade-tolerant species and preserving multiple age classes within the stand. This can be broken out into a couple of different systems, silvicultural systems that we're going to describe here. Group selection systems, single tree selection systems, and crop tree and mass tree release systems. So with uneven age stand, the goal should be to retain a diversity of age classes in the residual stand. So this chart shows kind of an ideal situation in reducing the number of trees on the site, but also keeping a diversity of age classes on the site. Often the most limiting factor is the lack of smaller diameter trees that we were talking about earlier, the regeneration. So group selection harvests are essentially small clear cuts. Usually the diameter of the opening is less than twice the height of the dominant trees of the adjacent stand. So those small openings kind of favor species that have moderate shade tolerance and will regenerate under partial shaded conditions. If you expand the openings to larger openings, that allows more light to reach the forest floor, and they're generally used to regenerate species with low shade tolerance when it's desired to have multiple age classes represented in the forested stand. So here's an aerial view. You can kind of see that cut right in the middle there that's partially shaded out. This is an aerial view of a group selection cut. You can see that as the day progresses, there's different portions of the harvest unit that are going to receive sun and different portions are going to receive shade. So this is usually an appropriate treatment for regenerating oaks and other shade intolerant or mid-tolerant species. So oak regeneration typically requires a minimum of about 1 acre for group selection cuts. Single tree selection is a harvest method where only individual trees are removed. This creates very small canopy gaps with minimal additional light reaching the ground level. The understory generally remains shaded after the harvest, and this really does favor shade-tolerant species. Pre-release is generally an uneven age system that allows for competition to be reduced from the preferred trees on the site. So when this is done for wildlife, this is releasing the competition from usually from preferential mass-producing trees, like those that are going to create hard mass like oaks and hickories and walnuts, or soft mass like black cherry is my soft mass example. So the competing trees are usually removed from at least 3 sides of the residual trees. that is not a silvicultural system, and we don't want to display it as a silvicultural system, but it's important to know about it, is high grading or diameter limit cutting, sometimes referred to as a select cut. It's often used interchangeably, those terms, with single tree selection cutting, but that's inaccurate. So diameter limit cutting is essentially harvesting trees above a certain stump or stem size by design, rather than within all the size groups. So diameter limit cutting is really removing the best, removing the highest graded trees, or cutting the best and leaving the rest. And so ultimately, this favors short-term economic advantages and leads to some pretty significant resource concerns on the site. And it's usually pretty tough to recover from a site that has had diameter limit cutting. Here's kind of a simplified chart of what that looks like. Essentially, in this example, on this diameter limit cut or high grade cut, everything to the right of the vertical dotted white line would be cut. So that would eliminate all the seed sources of the black cherry. That would eliminate the most mature seed sources of the white oak, and it would really favor the maples on the site, at the expense of the diversity of the site. So this is the primary way that private forest lands get cut. And it was estimated a couple years ago that up to 38% of Pennsylvania's forested stands on private lands had been high graded in the past. So definitely contributes to a major issue in Pennsylvania's forests. Okay, quickly, I want to keep an eye on the time, but also just want to touch base on how NRCS does assist with forest management. So NRCS's involvement in both silviculture and forest management is reliant on partnership and proper planning to achieve sustainable and desired outcomes for the private landowner. That's done through determining the landowner's objectives, evaluating the conditions of the forest, determining if the existing conditions constitute a resource concern, planning, implementing practices, and certifying. That's done through the development of forest management plans in partnership with consultants. Certification is often done in partnership with the DCNR Bureau of Forestry. We have an agreement with them to assist and tap into their expertise at the local level. So this is kind of, in general, this is kind of how we get from point A to point B, the current stand condition. And we implement conservation practices that could be brush management, herbaceous weed treatment, sometimes could be prescribed fire. We're not doing that a ton yet in Pennsylvania. Other practices like tree and shrub establishment, early successional habitat, and forest stand improvement in order to get to the desired stand condition. And often it is not just one of these practices. It's a systems approach in order to get to that desired future condition, the desired stand condition. So in my remaining time here, I want to address resource concerns and how a forest management plan might recommend conservation practices, and also identify prescriptions and acreages of treatments based on inventory and achieving those desired future conditions. So one of the most typical conservation practices that you might see, especially tied in with silvicultural systems, is this forest stand improvement conservation practice. This includes changing species composition, the structure and the tree density by cutting and removing trees from a site. So this can include silvicultural activities that we talked about earlier, like crop tree release, shelter wood cuts, patch cuts, forest openings. It can also include, associated things like removing some of the lower understory shade, low shade removal, or other regeneration methods. So this conservation practice is often employed to modify the stand density to increase plant productivity, improve habitat, and also assist with rehabilitating degraded stands where there has been some sort of unsustainable forest harvest, like high grading, where that's occurred. This is another shot of a post-treatment after a forest stand improvement cut. So this cut opened up the canopy, left behind some scattered large seed trees that will help to populate the understory and create forest with multiple age classes. What you don't see, because this is in kind of a dormant condition right here, what you don't see is the invasive species treatment that occurred prior to getting to this point. The control of non-native invasive plant species like multiflora rose and mile minute or hay-scented fern. Things that if you open up the canopy and provide a lot of sun to, they're going to go crazy. So that is part of the systems approach. You really have to plan for controlling, in most cases throughout Pennsylvania, controlling the invasive species before there is any consideration given to opening up the canopy. So we follow the conservation practice standard for forest stand improvement when planning silviculture treatments. And like I've been mentioning, there are several other associated conservation practice standards, like brush management, herbaceous weed treatment, and early successional habitat. So, so within the forest stand improvement practice, there can be several methods employed. I'm just going to highlight a few methods in our remaining slides here. So thinning is often used to adjust that stand density by cutting unwanted trees in order to improve towards meeting the client's objectives and improve some of those understory light conditions to promote regeneration and the desirable species. It can be sometimes preferred to leave the residual woody material on the site to create a protection barrier for the trees that are actually getting established as understory regeneration. Chemical thinning, it kills the undesirable standing trees, but leaves them on the site as standing dead trees or snags. So hack and squirt method is often effective for killing some species like tree of heaven, because the herbicide put into the hatchet wounds can help kill the root systems of the tree, which reduces the chance for root suckering. If you know tree of heaven and if you ever tried to just cut it off, you will get a million tree of heaven sprouts coming up from the root system if you don't use some sort of herbicide method like this to injure the tree and kill the root system first. Chemical ground control. This is essentially a foliar treatment or a pre-emergent application of herbicides to reduce the competition from invasives or undesirable species. So in this picture, this guy's treating hay-scented fern. This type of treatment is really often necessary before there is any sort of thinning or manipulation to the forest overstory that allows for increased light levels into the understory. Basal bark or basal stem treatment of herbicide is essentially concentrates the impact to larger stemmed undesirable species like striped maple. This also leaves standing dead trees and the brush in place and allows for a more precise kill than a broadcast or a foliar treatment, and can help control the understory light conditions. You can also see some heavy mechanical treatment. This can include equipment like this masticator on the left or a feller buncher on the right to adjust stand stocking rates or to remove undesirable species. This can be used on even-aged or or uneven aged forest, depending on the size and the objectives of the treatments. And covered a lot of information. I'm going to leave you with my contact information here and a picture of a beautiful low intensity prescribed fire that is doing a ton of good in this oak forest ecosystem. And I believe we have some time for questions.
Thank you, Peter.
That
Any
got us a little
questions?
bit back on schedule, maybe?
Yeah, thanks. I got us behind, so I appreciate that, Peter.
Oh, that's not your fault.
It's 100% my fault. I was the presentation that ran long. So any questions for Peter? Nothing in the chat, Peter.
And that's fine. And I do appreciate you guys' attention, and hopefully you're able to get out on onto some forested properties and enjoy visiting and learning more about forest management. I do encourage you to tap into the local forestry resources that you might have available to you. Like I mentioned, we have an agreement with the DCNR Bureau of Forestry, and we utilize the service foresters pretty much within every county. So if you are going out to a forested site and taking a look, please tap into the local DCNR forester or the local NRCS forester that you have in your particular area.
All right, thanks a lot, Peter. And we will get to see you, or anybody that's going to be attending the Thursday and Friday session, we'll get to see you on Thursday of next week. So
operations out there, and yeah, we're gonna see some of the forestry work at Fort Indian Town Gap next week. So that's gonna be kind of exciting.
Lots of fun. Hey, thanks, Peter. We appreciate it. And with that, we'll transition to the next presentation. So our next presentation is going to be on ag waste planning. And our presenter is Anna Tarosky, who's a soil conservation technician out of the Lebanon office. So Anna, good to have you there.
Hey, Tim, can you hear me?
I do. I hear you well.
Awesome. Okay, I'm going to get presenting here. It looks like my computer can you guys see my screen?
Somebody see it. I do see it.
Okay. All righty. So yes, like Tim said, I'm going to be talking about agricultural waste management systems. I'm a soil tech here in the Lebanon office, and I'll start with a joke. So what do you call a person that sells cow poop? An entrepreneur. So take a minute to laugh at that one while we get started here. So ag waste management systems. These can be very complicated systems with a lot of moving parts, and it's often a really big undertaking by the landowner. So we need to do our due diligence to make sure that we are considering everything we need to consider and putting together a system that will work for them. And so that is a team approach. We usually have a decision maker, which is the landowner, not always the landowner, sometimes the farmer, sometimes not the farmer, sometimes landowner, sometimes it's grandpa who's retired 2 years ago, but still wants to have a role in the farm. Decision maker, a planner, and then an engineer or a technician. Like I said, these can be complex, and an ag waste management system is a part of a total resource management system. So we need to be considering how it's going to play a role in all of these systems when we are doing this planning an ag waste system. And we have to make sure that a planned action is based on resource concern. Sometimes we're going to go out there, we're going to talk to farmers about their ag waste system, and they want to make a lot of changes, but we really need to be looking at the resource concerns and making sure that the changes we're making are addressing a resource concern. And all of these parts need to work together, or we will have a weak link in our system, and that's not going to be good for anybody. So, doesn't look like my screen wants to go there. There we go. Some of this that I'm talking through here in the beginning, you guys, is going to be a little bit of a review. like this, we plan to protect natural resources, including soil, water, air, plants, animals, and social, cultural, and economic resources as well. And what we hope to get out of this ag waste management system is that we're protecting these natural resources and we're making an improvement to the resources and to the farmer or the landowner, that we're improving their system. Okay. So in this training today, we're going to review the 9 steps of planning. I'm sure you guys have heard them many, many, many times, but they are the basis of what we do here with NRCS and conservation planning. And so we always go back to them. No matter how long you've been doing this, you go back to this. This is what we do. We're going to identify the parts of an ag waste management plan. We're going to discuss some options that may exist. That's going to be a bulk of my presentation today, just going over a lot of photos, a lot of things that you guys might see out there. And it will not have everything. And every time I go out to a farm, I usually end up seeing something new or learning something new about a system that I've worked on before. So yeah. And we're going to discuss a couple other considerations that we need to be aware of when developing one of these plans. We have to consider the whole system, and that's something that I think sometimes can get lost. We look at ag waste and we just think manure. We're looking at the manure and we're looking at how are we going to treat that resource concern, but that manure is part of a much bigger system, and we need to be looking at how this ag waste management plan plays a role in the cropping system or in any other system that exists on that farm. And everybody who plays a role in the development of this ag waste management plan, your engineer, your tech is the person we think of a lot when talking about a plan like this, but them, the planner, the landowner, if you have other people involved, we're all responsible for making sure we're considering the full system, from manure production to storage to field application. So probably have seen this before in this boot camp. So in boot camp 1, I believe you guys focus primarily on 1, 2, 3. Boot camp 2 here focuses on 4, 5, 6. Ag waste management plans kind of rely on this 4, 5, 6, but I'm going to talk a bit about this 3 because inventorying, getting a good inventory of resources is what is going to allow us to do a good analysis of that resource data and be able to formulate good alternatives. And if we do a good inventory, we can also maybe work on eliminating alternatives and kind of streamline this process a little bit. So planning process, steps 1 and 2. So first step, identify the problem. We've all heard this before. Why are we planning? Is there an opportunity to improve something? Is there a shared concern between us and the landowner? And I said before, who's the decision maker? We say decision maker. I tend to use producer or landowner, but producer's not always landowner. Landowner's not always farmer. Sometimes there's different people. So from that first step, we need to be figuring out who's going to be the decision maker. Sometimes I laugh sometimes when, like I said, with the grandfather, sometimes you go out and you're talking to the son, he owns the farm, he's been running it, but grandpa or dad retired 2 or 3 years ago. He retired. He said, I'm done. I'm not farming anymore. It's all yours. But he still plays a role in what happens to that farm a lot of times. So making sure that we know who the decision maker is going to streamline this process a little bit and make sure that we're planning a good system. And he might have input too on what has happened previously or what they tried before and didn't work. And that's something that we need to inventory and consider. When we're identifying the problem, do we have any regulatory things that we need to address? And are they already involved in a program? Or do they want to be involved in a program? And do we need to do something to address a problem as a result of that? Step 2, determine the objectives. You've heard this before. What does everyone want out of this? Agency issues may differ from owner issues. The best example I have of this is we go out to a farm and you see a compost pile with mortality in it, just sitting there all alone, exposed to the elements, leaching nutrients all down. We see it and we go, oh, hey, that's a nutrient issue. That's a water quality issue. We need to treat that resource concern. The farmer he doesn't view it as a resource concern. He just doesn't want to handle a big pile of sloppy stuff when he's trying to get his animals composted. We might end up at the same conclusion. Our alternatives might be the same, but our objectives are different. And it's important to acknowledge those different objectives because those can play a role in how we plan these systems. So step 3, inventory the resources. I said before, this is a very important part, and it's a lot of things we have to look at. But if we do a good inventory of these resources, if we gather enough information, then we can come up with some really good alternatives and plan a really good system for the producer. And it's our job to be looking at all of these resources and having a good conversation with the farmer about what are his resources and what's going to go into affecting the type of system we plan and the different parts of the system. So type of operation, the biggest thing I think of with that is what kind of manure are we dealing with? Are we dealing with a liquid or a solid? And do we have any biosecurity purposes or biosecurity things we have to consider? Right now, at least here in Southeast Pennsylvania, I know we're dealing with some heightened biosecurity around poultry and birds because of the avian flu. That's something that's important when we're even thinking about where we might put a manure storage. If he's going to have somebody coming in that needs to get to that manure storage regularly, but he doesn't want it necessarily right near the chicken houses. So from the beginning, that type of operation right there, we're already thinking about how this might affect what we're planning. And does he have multiple types of animals on the property? Anymore, I feel like I see a lot where you might have different animal groups, or you might have chicken houses at the back end of the property and a dairy or some beef at the front end, and they're handling different types of animals, and that affects kind of how we're going to plan this ag waste management system. The size of the operation, is this a large or a small operation? Pennsylvania has some really, really big farms, and we also have a lot of small farms. What their size, what they're able to invest into a project, and how they want to manage it is all going to play a role in what we plan. Site location, township, floodplain, neighbors, things like that. Are we going to have township issues that we need to be considered about? Are we going to be in the floodplain? Do we have neighbors right next door? Site location, I also think part of the county you're in. I know my county, we tend to have a lot more chicken houses on the northern end of the county, and sometimes that might be something that comes in that plays a role in it, or you have a guy or a farmer who is converting something in a certain part of the county, that all can play a role. And that's kind of more social, but still it can play a role, and it's something to make sure we touch upon when we're inventorying the resources. Current operation, what are they doing right now? This is probably the biggest thing. What is happening right now? That's the beginning conversation we can have. What's going on right now? What's going good? What's not going good? Documenting that. We can sometimes already take out an option if that's his current operation and he's saying, yep, that's what we're doing is not working. Land availability. Can they give up land to make a change? Do we have to, if we're considering planning a new system, does he have the land available to install that new system, or does he say, you know what, no, I need all of the land, everything I crop is what I need to crop, I can't take any of that out of production? So okay, what's his existing system then? Can we do anything to improve the existing system? Soil, what are the soil types at that site? Can we build on them? With soil, a lot of times I think of fill. There's been a lot of fill brought in over the years, and can we build on that fill is something to consider before when we're talking about where we're going to place something. And even can we build on not fill, but existing soils? I know a lot of our engineering has different bearing strengths that we need, soil types that we need in order to be able to build on it. So before we're committed to doing something there, we need to be looking at the soil. Topography, where can we put something? Do we have steep slopes? Do we have flat areas? Do we have floodplains that we need to be considering? Climate, heavier rain in certain areas. Do we have to be considered about snow? How much do we have to be considered about snow? And even localized climate. I live and work in Lebanon County, but I'm originally from northeastern Pennsylvania. I drive up that Route 81 all the time, and I know there's a place right in the middle of it that if you hit it at the right time, it's rain, then snow, then rain all the time, or driving back through there after a storm, it's always snow, and then there's rain on either side of it. So that's something that's really localized. And talking to a farmer, you can get a grasp on that. You know, he might say, you know what, yeah, I'm a little bit higher in elevation, so I always get a little bit more snow. Things to consider when we're planning these systems. Geology, sinkholes. Do we have to be considering sinkholes? Crops. What does he grow? Is it a main source of income? You know, is he selling this crop, or is he using it to feed his animals? And what he crops when can affect on our length of storage. How long does he need storage for, depending on when crops get taken off? Labor. This is a really big one anymore. Labor availability. Does he want to have a lot of labor? Sometimes we look at systems and we pay a little more to put in something that's a little less labor, or we pay a little less to put in something that's a little more labor. Did I say that right? I don't know if I said that totally right, but I'm sure you get what I'm going for there. And does he have children or family that are getting involved in the business, in the farm? We used to be where the son would grow up and it would be kind of a no-brainer that he would want to take over the farm and be involved. But unfortunately, I don't know if we see that happening as often. So that labor isn't there all the time. And getting and hiring labor is getting more expensive. So equipment, what equipment does he have? We need to build systems that are going to fit his existing equipment if he plans to keep that equipment. We don't want to build a system for a farmer and he needs to buy new equipment, and that's an unintended expense that he didn't think about, or we didn't think about when designing it. How old is the equipment? Maybe he is thinking about getting new equipment, so we shouldn't design to the old equipment, things like that. Level of management. This is another big thing. A lot of producers that we work with work off farm as well. They're not necessarily on the farm all day, every day. So when designing a system, for somebody like that, we can't necessarily design a system that requires a daily management because they might not be there or be able to put in that time every day. Adjacent land use. Do we need to worry about neighbors? Odor, that's a big thing. Do we need setbacks from property lines? If what is on that property next door, and does that affect a setback? Travel routes, how is he getting in and around the farm? You would hate to build a system that he can't get his equipment back to. Something to be considering. Maybe we're going to place something in a different place because it's easier for him to get back to. Laws and regulations, townships, local ordinances. Do we have stormwater things we need to consider? Odor's a township thing that I see a lot of times. Utilities, overhead and underground pipelines. Well, overhead utilities, underground pipelines, PA1 call. We always have to be submitting that PA1 call. We don't typically do that until we're in the design stage, but having a conversation with him about, hey, do you know if there's any underground pipelines? Because again, we don't want to plan something right over a pipeline. And now we've done all this work and we've gotten to the point where we're like, oh, no, we can't put that there. Expansion of the enterprise. Do they want to get bigger? How much bigger do they want to get? Flexibility, what options do they want in case things change? Or does he have different ways that he wants to be able to manage this based on a wet year or a dry year? And that's a whole lot of inventory of resources there, but there are even more things that we need to be considering. And a lot of these, as you're talking with the farmer, they'll become addressed, and you don't necessarily have to point them out exactly, but all things we need to be considering. So step 4, here's what we're going to be talking about primarily: analyzing the resource data, and the production, the collection, the transfer, the storage and treatment and utilization of ag waste. I tend to say manure because that's what we think of mostly with ag waste, but it's not just manure. It includes mortality, it includes milk house waste, it includes silage leachate. Any agricultural waste that's produced is part of this process. And when we're analyzing this, we have to analyze how this system will work for the landowner and what will work for the land. Sometimes landowner wants to do something that just won't work for the site. But that's what we need to be thinking about when we're analyzing the resource data. Steps 5 through 9. Formulate alternative solutions, evaluate alternative solutions. we need to develop plans to address resource concern and achieve goals for the land, and evaluate alternative solutions. How effective are these alternatives? What will they accomplish? It's good to talk about the pros and cons to each option. When we're talking about different options with the farmer, don't be afraid to give the con, to say, hey, this might work really well for this, but maybe you need to consider if this is the best option for this case. Sometimes that might be he wants to handle his manure as a liquid, but maybe it's not super liquidy. I've had a beef farmer who wanted to handle it as liquid because that's what he was used to. He used to work on a dairy farm, and it was like, oh, well, unless we're adding water to this, and we really necessarily shouldn't be adding water to it, this might not work. But evaluate all those alternative solutions and give both sides of it, pros and cons. And sometimes cost plays a role in that. We don't get to see costs very often, but encouraging farmers to go out and talk to contractors to see what the cost difference are, that plays a role. It's happened. I've had it happen a couple times where a farmer's set on something. He's for sure this is what he wants to do, and he goes and gets a couple quotes and goes, oh boy, we need to talk about this again. This isn't going to work. We can't put that much money into this process. And step 7, a client determines a course of action. This is the landowner's project. We do not get to decide what happens. At the end of the day, we walk away. We help them implement this and we leave. So if there's issues, we don't really get to see that. So we don't want to be making decisions for the farmer without that. We want them to be making the decisions. We can give them as much advice as we can, but they determine how they want to proceed. Step 8, client implements a plan. We provide technical assistance. Designs are developed based on standards and specs, and practices are implemented. And 9, evaluation of the results of the plan. This could be spot checks, program appraisals, or visits back to the farm. Different areas of the state and different field offices do this a little bit better. For me, the way I always handle it is sometimes with these ag waste systems, you're putting in multiple parts and you complete one part and you're working on the other part. And I always try to say, when I go out for that second part or that third part, say, hey, how are the other 2 ones working? Or you go out and you get, it's a little bit past and the farmer just had a question, you stop that there to see him, hey, how is it working? Any chance you can get to get an evaluation on how the system is working for him at the end of the day, at the end of the project is really good. So, ag waste management system plan details. So we need to have plans and designs developed, and they need to be based on standards and specs, and they need to provide adequate information for a contractor or landowner to construct the project, meaning they need to be somewhat simple. The purpose of the plan is to have expectations written down and to explain how the system should be installed and how the system should work. Contents, a description of the system, a kind of plain language description of the system, not getting into the nitty-gritty of it, but an overview of what are we actually doing here. A sequence and schedule of installation. Sometimes with these big systems, you have multiple contractors involved or multiple technicians checking when these are being installed or different things like that, and having a sequence written down really helps to manage expectations. That's a business phrase, managing expectations, but I've found that can really avoid issues down the line if you have a meeting and you're able to say, here's what is expected as we move through this project. Operation and maintenance is always contained in an ag waste management system plan, and these projects really live and die by operation and maintenance. They are an expectation for the landowner of what needs to be done in order to operate and maintain the project. So that could be when must a tank be emptied? So when it's full or 6 inches above the top with a liquid storage, that's when a tank is full. That 6 inches is freeboard. We don't want to go out and see manure right to the top of the tank. Where will manure be scraped to or moved? What if it breaks needs to be repaired? When to check for damage. So after big storm events, we need to go out. After big wind events, maybe we need to go out and take a just quick look at that roof to make sure everything looks the way it should. When should we check the perimeter drain of a tank? So if you have a tank that's going down and you're not pumping out, that's a reason to be concerned. And that should all be spelled out in the operation and maintenance. What we think of probably most with an ag waste management plan is the engineering details, drawings, and specifications. That's the biggest bulk of this. That's all the information on how it should be installed and the specifications that need to be met when it is installed and designed. And the designs need to have enough detail where someone could pick it up and understand what needs to be done. I try to keep them fairly simple. A lot of times we work with contractors who have done this kind of work or people who've done this kind of work and they're familiar with it, but you never know who you're going to be working with. So we need it in fairly clear language and understanding that somebody who's never seen this project could pick up a design, take a look at it, and understand what needs to be done. And all manure storage projects must have an accompanying nutrient management plan. That'll help to dictate where, when, and how manure is spread when it's removed from the storage system. And it's kind of a way to make sure that the system will work for them. It kind of does the math on the far end of it of production all the way to application, and that what we kind of have in the middle, that it kind of makes sense in the big scheme of nutrient management on the farm. And this should also have some information on how the relationship to other management systems and where is how is everything connected? Where is the manure generated? How will the manure get to the storage? How will it get from the storage to the field? Again, we don't want any weak links because we only focus on one part of the system. Ag waste management key functions. This is a great visual representation of what we kind of need to be considering when it comes to the functions of a system like this. Production, roof gutters and downspouts. When I think of production, well, we can't really put anything else in the cow to make it produce manure a different way. So clean water exclusion. Where it's produced, we want to keep clean water clean. Roof gutters, downspouts, diversions, keep clean water away from the production areas. Collection. So manure has been produced. How do we collect it? Alley scrapers, flush alleys, manure pack, gutters. And we'll be taking a look at some photos of most of these things in this chart here. Storage. How are we storing the manure? Ponds, tanks, dry stacks. Treatment, does the manure need to be treated? If so, how are we treating it? Is it going through a lagoon? Does it have to be composted? Do we have to separate our solids? Do we have to settle our solids out? Or how does the farmer want to treat his manure? Does he need to treat it? And then the transfer between these systems. So from our collection to our storage, how do we transfer from our storage to our treatment, or our treatment to our storage? How do we transfer? And even then from treatment to utilization, or from storage to utilization. So how do we get the manure from where it's produced into our storage and then out of our storage to where it's being utilized or spread? So now we're getting into the pictures, the fun part. No more words all over the screen. So roof gutters. In this image up here, I'm sure you all have seen gutters before on houses or whatnot, but this is a project that I worked on. This is a drive-through feed alley. It's got headlocks on both sides, and we have gutters all along this roof here that's taking it underground. This is his existing barn back here, and we put on new gutters and new downspouts. There's quite a complex pipe work underneath here, kind of tying these all together and getting them outletted. But this whole system goes into a short-term storage over here that gets pumped to a big round tank, and we're keeping a whole lot of clean water out of that system for him. This is a drop box. Again, you guys have probably seen these, maybe not on farms, but on highways. Anytime after a big rainstorm, there's a puddle at a low spot, it's probably a drop box underneath it. But we install these to collect clean water before it gets to a storage or before it gets to a manure, a trafficking area or an animal area in which there is manure. So we'll talk about waste collection methods. So as you guys go out to farms and you see different things, there are 100 different ways to do this. And what I'm trying to do today here is to just give you some visuals on what you may see out there. And you might see some of these, you might never see another one. I'm not sure I've even seen any of these in action. Or I've seen some of them in action, but not all of them in action. But kind of an idea of what might exist out there. So we talked about production, and all we can really do with that is clean water exclusion. We can't change how the manure gets generated, but we can have different ways on how it's collected. So some options that might exist are a direct scrape. So farmers, the manure is produced and the farmers directly scraping it into a storage. An alley scrape, there's an alley within the barn, and there is a system that scrapes that alley on a regular basis. Chain and flight, it's a gutter cleaner that has a chain with paddles that are pulled through the gutter to the storage and or transfer location. Shuttle stroke, it's a gutter cleaner that has paddles that open up when pushing a short distance and then are pulled back and the paddles close. And there's some photos of these. I know this is kind of hard as I'm explaining it like this to see, but we'll see some photos. A flush system. So we have a barn on it, the whole barn's on a 2 to 3% slope. We have big tankers of water, and at regular intervals, the whole barn is flushed with water. That's then collected somewhere and solids are settled out or managed as entirely as waste. Slatted concrete gang slats, slatted floors are really common. There's basically the floor of the barn is concrete with holes in it, and as the animals move around and they produce manure, manure falls down through the slats into an under barn storage. As they walk on it, they help to move it down in through the slats. This is a really common system that's very low daily maintenance. So the storage is there, the cows produce, they kind of work their own manure in, and farmer can kind of stay out of a daily scrape. Gravity gutters, so gutters that will collect the manure and are on slope, and gravity naturally kind of moves the manure down through. And you might see a combination of the above. So this is like super basic mule powered manure pushing system. So tie stall barn, this would be attached to a mule and either pulled or pushed through the barn. These paddles would run in the gutter and manure would accumulate in front of the paddles as it's pulled through and would clean the gutter out. This is not super common. You'd see this probably in an Amish or probably an Amish system. From what I hear, this used to be a lot more common, but over time things have changed. So a tire scraper. This photo up here is actually from the same farm that the photo I showed before with the gutters it's the same farm. So he has a big lot here that all drains to this push off, but he does some daily cleaning with this tire scraper. So this attaches to a skid loader and he can push it around just kind of like you can see down here. The advantage of this is there's quite a bit of, he can really kind of get into corners to get things, relatively speaking, to get things cleaned up. The negative is to push a lot of manure, it takes a lot of moving around. So alley scraper, I mentioned that. This system has a concrete alley here. As you can see, these are tie stalls. So cows produce manure, and then this alley scraper is automatic. It's on a chain that you can see right there. And over time it drags and collects the manure and pushes it out. This is the end of this alley scraper. So I'm guessing this is an under barn storage or an underground storage. And this alley scraper, when it runs, it pushes all of that manure in there, and then it would rotate around or be pulled back in the opposite direction to reset for the next time it needs to be cleaned. Tie stall barn again with extra large gutters. So this is when I've been saying gutters, this is what I'm talking about here. So cows produce manure, manure gets in there. You have a cow actively producing some well, liquid there. And this gets filled up over a couple days and then cleaned out with a chain and plate system. So there's a system that'll actually come through and scrape this out every couple days. So this type of system could have a longer storage. This one from down here, we can say extra large gutters. So they have a couple days between scrapes. Another system could be a smaller gutter that needs to be more regularly scraped. And when we're thinking about those different options about what's already there, I'm sorry if you guys can't hear me. They are mowing the lawn right outside my window right now. Okay, it looks like the lawnmower's gone. But so when it comes to management systems, something like this, you know, the gutters are okay for a few days. It doesn't require any input for those for a couple days, where a system with smaller gutters has a little more labor needed because that needs to happen more often. So a roofed facility with a slatted floor above a storage tank. So we're roofed here, so we're excluding our clean water. We don't have to worry about any rainwater falling on here. Tie stalls and the cows are fed over here. There, you can't really see it in this photo, but there's headlocks over here. And cows produce manure mostly where they eat. So manure is produced, and as the cows walk through here, they're walking kind of moves this around and pushes it down through these slats. This is a good picture of what the slats look like clean. Those look like brand new slats in my opinion. Once cows get on them, they don't look that clean, but yeah, those holes are designed and manure gets pushed through them, so you're not really going to end up with any huge chunks of manure down in that slatted storage. But that slatted storage has to be a primarily liquid manure, because the only way to get the manure out of there is to pump it. Again, tie stall housing, can you tell we see a lot of tie stall housing with a conventional gutter cleaner? So this is where I'm saying maybe we have a smaller gutter here. I don't know why that happened. But smaller gutter here. So this might have to be cleaned out more regularly. It does look like this is pretty dry stuff down in there, where with the other one that we were looking at, looks like maybe they were anticipating that be a little more liquidy. So gutter cleaner will run through here and scrape this out probably on a fairly regular basis. So underfloor collection for duck waste. So ducks are up here, they live on top of this meshing, and as they produce manure, it falls down through into a storage underneath. These types of systems, this and the slatted, are very, very passive systems for the farmer. So it kind of just handles itself for the most part. It's not something that requires them to scrape every day, or be on a daily or a twice a day or something like that, actively a part of it. So when we were talking about looking at how much labor does the farmer have or how much input can he have, that's something to consider when you're looking at this kind of system. Compost bedded pack for dairy cows. I've seen a lot more of this. So the way this works is basically a bed pack area is an area that the cows can kind of loaf in. And the idea is that with this is that it actually kind of manure gets produced in it, bedding gets added, and it kind of composts itself. So a system like this does require a fair amount of input from the farmer, usually every day or every couple days. Extra bedding is added, and it also needs to be rotated. So farmer can come in with a skid loader or another type of equipment and actually kind of, for lack of a better word, till this area to kind of aid in that composting system. So this is, I've heard from one farmer that I have that does this. He loves this. He says it's really, really healthy for his cows, but it does require a lot more input on his part. This is a Virginia style monoslope roofed heifer facility. So with a slatted floor above concrete storage tank. So this is something that this type of setup, maybe not this Virginia monoslope roof, but this kind of system here is something that's a fairly common. So we've got headlocks out here in this, what I would call scrape alley between the headlocks and this back bedded area. There's slats and there's an under barn storage. So cows produce manure where they eat. And so they'll produce manure, it'll work its way down into the slats, but they have a bedded pack area back here. And looking at this looks a little more sloppy than I'm used to seeing. Maybe the management isn't quite there at the point this picture was taken, but yeah, this is a pretty common setup. Even if you don't see this monoslope roof, this kind of feed alley in the front, scrape alley, and then bedded area in the back is a fairly common thing that I've seen. And I had to put this in here. You may not see this, but they're here. Robots are in agriculture. This is from a farmer I'm working with right now. You guys may have heard of robotic milkers. This farmer's putting in a big, brand new facility with robotic milkers, but right now he has this little robot. And now this really this one isn't really necessarily a collection, but what this does is he's got a drive-through feed area here with cows on both sides, and this little guy comes out shortly after the cows are fed and pushes the feed back towards the cows. So as cows are eating, they'll tend to push the feed as they're reaching for it out, and normally farmer has to come in and kind of sweep it back towards them, but this little guy does that for him. And in their new facility that they're putting in, they're going to be having a robot that put in a slatted storage that'll actually run along the top of that storage and kind of along the top of the slats and kind of work the manure to help get it down through the slats even quicker, and has a cubic footage to actually suck up large chunks of manure and take it out, like areas that haven't gotten worked down into the slats. So I had to put it in here because it's a farmer I'm working with, and they're out there. So if you see them, don't don't be surprised. So we've collected the manure. Now we might need to transfer it. So we've scraped the manure, or we have it in the slatted storage, slatted storage, it's worked down through, we have it there. Now we have to transfer it somewhere. So some of the things you might see: pumping, so a ram pump or a piston pump, a pull plug system. So something fills up and then they pull it and it all flushes kind of in one fell swoop. 3 to 7 day holding tank with pump, and then a transfer to storage. So you have a smaller storage essentially close to where the barn is or the barnyard is, and then you have a larger storage somewhere else. This happens a lot if our area in which it makes sense to have the barnyard is not necessarily the area in which it makes sense to have the manure storage. So we can have a small tank that he can scrape to regularly, or the barnyard can flow into, and then it pumps to our larger 6 month or however month storage somewhere else on the property. A gravity hopper. So manure gets scraped into a hopper and or pushed into a hopper, and it kind of works its way with gravity. Gravity flows in a pipe to the storage, or some combination of this above. And again, I don't have everything in here. You're going to go out and you might see something different. But if you don't know what is happening, do not hesitate to ask the farmer. It's our job to ask and make sure we know what's going on. And sometimes you can't see these things. You might see the gutter cleaner, but maybe the gutter cleaner goes to a hopper and now there's a pipe underground gravity pipe, and you don't see it. But ask. Farmers are often very happy to talk about their system, and especially if you're trying to help them improve that system, yeah, you need to know what's going on there. So another slatted storage here, but a short-term storage. So slats, we've seen a couple pictures of slats now, but this slatted storage underneath here that might hold maybe a month's worth of manure. And then there's a tank somewhere else that can hold 6 months. And so it's a passive system for about a month, and then the farmer has to pump to the bigger storage. So transfer, so a scrape transfer. This is a project I worked on. So there's actually wasn't even cows here yet. The project was just about finished here. Still didn't have his fence up, but this was a new facility. He has a scrape alley that would be scraped daily, basically, that would scrape out this door, and then he'd push it down and around. And this is the push off into the slatted or into the round tank. So again, this is a little management intensive, but this was going to work for him in this system. This is the way he wanted it. So this is a conventional box type manure spreader for solid manure. So manure gets produced, it gets scraped to here, and then it gets scraped and put into the box spreader. This is typically like a daily haul type system. We see these most of the time. If you talk to a producer that has this is a lot of work for him. This is very, very labor intensive. An electric manure pump. So you might see this manure, this goes down into the tank, and this is a pump that he can kind of turn on, flick on a switch, so to speak, and it'll pump to another storage. PTO driven manure. This is a PTO driven manure pump to transfer manure from short-term to long-term storage. PTO, I don't know if you guys know what that means. Stands for power takeoff, and basically it means you hook up a tractor to this pump in order to transfer it. This is something that you might see might be existing, and farmer might be happy with it, or he might have. This might be something that you're putting in for a new system, but it works off a tractor, and you need to. This is labor intense, where the tractor needs to be brought over and you have to be standing there actively partaking in this transfer type system. Some of the things you might see, manure chute or elevator. So manure kind of gets hauled up via this elevator. It's kind of an older system. I've never actually seen one of these in function, but they exist. This is kind of what a sand scraper in a cross alley would look like. So this gets filled with manure, sand laden manure, and this goes through and scrapes the manure through it. I mentioned the piston pump before. This is the pump. My guess is that there's a liquid storage either on that side or this side. Probably, it looks like there's a valve on both sides, so it could be either. And this would run and pump manure from your short-term storage to your long-term storage. This is an image of a manure being pumped. So this is our pipe coming up over the tank. This is a valve. So yeah, this looks like an 8-inch, maybe an 8-inch pipe coming up over there, pumping manure into your liquid storage. So maybe his short-term storage is way off somewhere down there, and he's pumping it up to his longer-term storage. So I mentioned before an alley flush system. So this is a big tower that's filled with either water or wastewater from somewhere else in this operation, and it runs through the barn and it flushes it. So you can see here this kind of full. I've never actually seen one of these run. I would love to. So if any of you guys have one of these systems or you see one of them, let me know. I'd love to come see one of these in action. Sand. We've seen some sand bedding, and sand really wears on mechanical parts of separation systems and scrape systems. So this is actually a really great option for somebody who beds with sand. So do we need to treat the manure? And basically when we talk about treating, we're talking about removing solids. So some things you might see: a static or vibrating screens, a roller press, inclined gravity gutters, a screw press, or flocculation. So this is what a screw press looks like. This screws the manure against this screen here, and the liquids come out and the solids stay in. This is a paddle press. So manure comes through here and the paddle presses the solids. The liquids get separated, the solids stay in this system. So long-term settling basin using weeping walls to dewater solids on a flush alley dairy. So we saw the flush alley before. All of that big flush, that water comes through and it gets into this basin and it sits here. And as the solids settle, the liquids can weep through these walls. This is a system that it kind of flushes. Actually, it looks back here. Yeah, that might be the intake or the outlet of the flush system into this. You can kind of see here too in this picture down here. I don't know why those are in there, but this looks like primarily solids, and most of the liquids have been out of that, have filtered out of that system. This looks like that's leaking a little quickly for my liking there, but manure solid separation with the Albers gravity screen system. Albers is a company but basically this moves the manure up, and as it moves up, the liquids drip back down, and solids probably get deposited somewhere up there. With treatment, we might also have to remove sand. We can do that with gravity systems or mechanical systems. Again, I mentioned before, mechanical systems, sand really, really wears on mechanical systems. So gravity systems tend to be what most people lean towards. And those gravity systems could include sand settling lane or settling basin. Mechanical systems include cyclones or other, I'm sure there's things out there that we don't know about. So this is sand settling lane. So the flush comes out of here, and this flows through here. And as it flows at the grade that it is, the sand settles out and the liquids keep moving. So this photo is looking from standing up here down out towards there. With these, the grade is super, super, super critical because if it's a little bit steeper, the sand doesn't settle out. If it's a little bit slower, you have other things settling out that you don't want settling out. So, but these are very common and especially for sand systems. This is showing a collection area for separated manure solids. So maybe they have some sort of chute or a screen press system or something in there. And the solids are being dropped out here, and those are getting scraped or managed to somewhere. So quick thing to look at though, this would be a resource concern that we would need to consider when we're out there. You think manure produced and now we're treating it well, you still have nutrients here in this dry stuff that we need to make sure we're managing. This is I believe a wave system. So manure comes out as a liquid and kind of waves like you would imagine at an ocean. As it deposits here, the liquids keep moving, but our solids can kind of get stuck here, and then they can get scraped and stored. This is mechanical sand separation equipment. So I mentioned before, sand can really, really wear on mechanical equipment, but they do exist out here if you're willing to keep changing things, or if you're willing to work with it, they're definitely doable. And if you don't have the space for a sand settling lane, maybe this is a better option for you. So this, I believe, is looking at from the other side of this. So this moves up, and I imagine what happens here is our liquids stay down here. They kind of drop out and settle out. And as it moves up, the sand gets dumped out there. So beyond the initial treatment of removing the solids, we can also have some more advanced treatment, drying our solids or removing our solids by flocculation, anaerobic digesters, or even composting our solids. So this is a drum composter. Dry manure solids go in here, it rotates and comes out as compost on the other end. There's usually a period of time in which it takes for manure to go through here. So when you're thinking about something like this, we have to make sure that we're timing it. We have enough time based on the manure produced to get all of our manure through the system without having a backup. Digester systems, pull plug, fixed film, or mixed. Fixed film is what we commonly see at wastewater treatment systems. A pull plug, 20 to 30 days it takes for them to work through the system. Or a mixed, so a digester in which there's some sort of mechanical action that's happening in order to work on digesting the manure. I'm not super familiar with a lot of these, but I know I keep hearing more and more about digesters, so they may be coming even more. I mentioned removing solids by flocculation. So this has a lot more of infrastructure with this type of stuff in order to get the system to work. So basically what chemical to it to basically bind the solids together and be able to more easily remove them. again, something you may see while you're out there working. Or composting manure solids. So these are windrows. This here would be driven down and would lay down on top of that row and turn it to aid in the composting system. Here you see a tractor rotating the compost. So that happens every so often to maintain the oxygen level, and it's a mechanical mixing. Storage systems, two types. We have aerobic and anaerobic. 99% of storage facilities in Pennsylvania are anaerobic, and that is everything we do. It is anaerobic. There's no oxygen added to the system. Aerobic systems do require adding oxygen, and there's usually a mechanical aerator as part of that system. So those two different types of storage, we need to be looking at factors affecting what kind of storage type we want to do. And of the anaerobic storages, we need to be considering bedding material and manure consistency. So I said before, if their manure is a liquid, we have to be looking to try and handle it as a liquid. If they're adding a lot of bedding, it tends to be drier. That means we tend to have drier manure. We need to be handling it as a solid. If they do bed with sand, we have to be looking at how are they going to take that sand out? How are they going to reuse that sand? Some places use recycled manure, so they can actually take the manure and they dry the solids and they can actually reuse it for bedding. There's some other treatment that happens in the meantime in between that, but are they doing that? Do they bed with sawdust or peanut hulls? All things we need to consider. And a little side note here, there are certain things that they can bed with that can cause very noxious gases to be produced. So really important that we find out what they're bedding with and how much. Geology, so we can't put certain storages on certain types of soils. I mentioned that once before. We have to know what soils are there if we're going to decide that we want to go with a liquid storage. Well, we need to make sure that we have the soils there that we can. If we have a high water table, that can really increase the cost of a project that we are trying to install. So maybe then it makes that project not possible. So space limitations, I mentioned that before. Do we need to go taller and do we have to go deeper with a smaller footprint because he can't take as much water or much land out of production, or maybe we can go wider and shallower and that works better for him. Current or future manure handling equipment. So what does he currently have? Where I run into this most often is in depth of liquid tanks. So they have certain depths of pumps or pumps that can handle certain depths. And if we install a tank that's too deep for his current pump, then he has to buy a new pump, which while is doable, isn't always the best option or isn't always an option when it comes to cost. And the cost of installation, there's a saying when engineers talk, and it's that you can build anything. You can design almost anything in the world, but the cost of the installation is what's going to affect it. So that's something we need to be considering. And then we need to look at site constraints in existing buildings. You know, we can't build close to certain other existing buildings for certain reasons. And even how does the farmer get in and out of his barn, site constraints like that. We have to be considering owner's preference, and we have to be considering program, cost share guidelines, and finances. So what do we have to meet if they're involved in a program and they're getting a cost share? What do we have to meet in order to ensure that we meet what they need to get that cost share? So manure storage options. Things that exist, earthen pit lined with treated soil or membrane. HDPE tends to be cheaper in Pennsylvania. Clay lined or treated soil lined pits tend to be more expensive. That can change depending on where in the United States you are and what is available to you. In-ground concrete tank is probably what's most common when it comes to a liquid storage. Those are the round tanks you're used to seeing. We also have above ground concrete or steel tanks, temporary stacking area on lot, remote stacking or storage facility, a roofed storage, and we can consider upgrading existing sites. This is an HDPE lined earthen storage with an access ramp right there. And this is a gravity fill pipe. So manure and leachate are piped into that pipe via are put into this pipe via gravity. It comes down and it fills up. Once it's pumped out, this ramp can be used to scrape out the solids. And actually this may be the leachate that's coming in at the side. Concrete tank with ramp. What we most commonly see is probably this, which is your typical round tank. This is a tank with a ramp. This ramp is used to get solids out of the bottom of the tank, which is really great if you need to be able to get solids out, but the ramp does reduce the ability to get good agitation, so even more solids can get stuck. So depending on something to consider discussing when you're talking about putting in a ramp, is it really necessary, and how does even putting in the ramp possibly affect the cost of the project? So this is the interior view of a slatted floor. We've seen a lot of pictures of slatted floors. This is one under construction. This is prior to any manure being put in it. So you can see there's concrete pillars and beams supporting those slats. This is the area that would get filled with manure. Steel storage tanks, always an option, but they do tend to be more expensive. A lot of times I've been out on farms and they already have one of these and are putting in a concrete one as well, but they're always an option. A roof stacking facility, super common. This facility is for poultry manure. You can't see it in the photo, but there are chicken houses over here. So farmer during his cleanouts will come and fill this, and then he's actually going to load out the other side. So he'll fill from this side and load out from the other side. And hoop roofs. This is a steel frame hoop building. This is for heifer pack manure and mortality. So he can compost underneath here and compost his mortality underneath here and store his bedded pack. Both of these, we don't have to worry about any rainwater. We've done our clean water exclusion. So short-term storage within a facility. This is kind of similar to that slatted facility we looked at earlier. So he's got headlocks along here. There's a scrape alley here, and the back of the barn is used for bedded pack. The way he is operating this is this corner back in here actually has some taller walls like that. And he scrapes fairly regularly, almost daily along this scrape alley here. There's no under barn storage in this one. And he stacks it back in this corner. And he's got about a month of storage here. And then every month he takes this, cleans it out to his larger storage, or if he's able to use it, he uses it. So that's how he wanted to run this system, and we were able to do that with him. So we need to consider barnyard runoff as well. There's some different options that you can have when we're handling the barnyard runoff. We can collect the runoff and directly transfer it to storage. We can hold it in a tank and pump it to the storage. We can transfer it directly. We can collect it in a settling basin and then to a tank and then dose to a VTA or a treatment system. We can reduce the runoff by diverting water with roof gutters, diversions, or other types of systems. This is that keep clean water clean that I mentioned. We can do slotted curbs. So small lots, the liquids on the whole runoff from the lot pools at the bottom. There's slots in the curbs and it's kind of dosed out in a slower way. The solids get contained on the lot, and beneath that is a vegetated treatment area or filter area for that runoff to be treated in. We can roof all or part of the site to reduce or eliminate the liquid runoff, and we can reduce the lot size or eliminate the site altogether. This is a settling basin off a concrete barnyard. So there's a barnyard here that all drains to here. So he probably scrapes into here, and also we have our runoff collecting. And this gets filled with the liquid and pumps the liquid out and then probably scrapes the solids out. This is a runoff collection to a basin with a riser. So the runoff gets collected into this basin and it fills up. The solids settle in here. The liquids can move through here into this riser and probably into an underground holding tank that's then pumped to a VTA. This is the barnyard again with a runoff collection. We have screens here to filter out our solids and only get our liquids into the tank. I would imagine there's also probably a small riser in there. that outlets into some pump tanks. And so these are the tops of the manhole accesses into the pump tanks. This is what I mentioned before with the slotted curb. This whole barnyard slopes in this direction. We have a perforation here in the curb. So when we have a big storm, this whole thing, now we would want to make sure that any of our big solids get scraped off of there, but that it's not laden with manure all the time, but the water would come down here, it would pool, and it would come out in through these slots in a slower fashion. So this should be grassed down here. This was shortly after construction, but this area would be grassed, and then we'd kind of get this runoff coming through there to this grass then would treat that area, that runoff from the lot. This is a roofed barnyard. So this was an existing barnyard that actually had a pipe collection that just was put in years ago and just was not working. So we put this barn up adjacent to the we put this roof up adjacent to the existing barn and have totally excluded any runoff that would get on that barnyard. Milk house waste. I mentioned before we have to consider milk house waste and how to treat it. What can we do with that waste? We can transfer it directly to the storage. We can pump to a holding tank or gravity into a holding tank and then dose or spray to a vegetated area, or we can collect it and haul it daily. And with any of these, there's always the daily haul option, but it requires a lot of work. And so a lot of times daily haul is the option that we're seeing and that we're kind of end up changing. And a little note down here, subsurface drain fills are not an option for milk house waste. So this is milk house waste being pumped into a storage. There's an underground tank over in there and it pumps once it gets full. This collection tank does have a float. So once the tank fills up, this kind of triggers the pump to pump then. When I mentioned before pumping to a VTA, what we might use is a spreader pipe. That's what this is. So what's coming out of here could be runoff from a barnyard that then runs through this pipe and doses this vegetated treatment area. And this is a really nicely grassed treatment area or waste treatment strip there. So we can also update existing facilities. Existing may be undersized or have safety issues we need to address. What we need to do is we still need to meet current standards. It may require a new lining system and it may involve major expense with no assurance that the storage will be manure tight. These require state permits and this requires PE approval. So if you are going to think about doing any of this, make sure you get your engineer out with you to be taking a look at this. And a lot of times when we're talking about upgrading existing facilities, what we may be addressing on a smaller scale is updating the fence around it because of safety issues, or they're pushing in and they need something more at the push-in. So this is a relining of an existing earthen storage. That's the earthen storage that was there, and they went in and they lined it with bentonite and then poured concrete over it. This is an existing concrete lined earthen manure storage. This may at one point have been, sounds like it was earthen and then they put concrete over it. That is a solution. Does look like they might have a push off or a dump in right there into the storage. We have to talk about silage leachate. So silage leachate is essentially what's produced as silage is stored. It's very noxious. It's very nasty. It can totally kill lots of vegetation. And so we need to be aware of it. This is something that can often get missed. You're looking at waste, you're looking at manure, you're looking at milk house, but you're not always looking at silage leachate. But sometimes this can be the nastiest stuff that's out there. So what can we do with it? We can collect low flow and then gravity flow or pump to an outside storage, so to our big storage, or we can dilute it by 50% and then dose or pump to a spreader pipe. So we saw a picture of a spreader pipe. If we're doing this with the silage leachate, we need to be very conscious that we are diluting enough, because you can pump it and if it's not diluted, it can totally kill your whole nice vegetated treatment area or waste treatment strip. We can add lime to neutralize it before direct land application. So again, we're being conscious of treating this prior to land applying. Or we can direct high flow to a grassed area of equal area according to Design Guide 10. If you're looking at silage leachate options, I sincerely suggest you read through Design Guide 10. Design Guide 10. There's a lot of good information in there regarding leachate and how we need to be handling it. So in this case of a direct high flow to a grassed area, we would collect the low flow and then direct the high flow to a grassed area. So I said, this is really nasty stuff. This produces a lot of nasty fumes. So safety first. This is a leachate pump tank. So the leachate's collected in here. And we've got our safety sign right next to it and our warning light. And so that warning light will go off if this starts to fill up. So we have a pump that's supposed to kick on, but if it doesn't kick on and this gets really, really full, we don't want it to overflow. This safety light comes on. This is a warning light and an alert that actually a producer had put right in at his barn. So he had a leachate collection system a little ways away. He probably could see it from the barn, but he put this right at his mixing area that he's in twice a day, every day. So if it does go off, it's somewhere where he can see it and he knows that there's an issue. So a low flow collection system, the way this works, we've got a big bunk silo here. The low flow comes in and the high flow comes in through here and goes through this pipe. When a low flow system, this drips down right into that other pipe. When it's a high flow, it can completely bypass that pipe. And the reason we do something like this is because you look at the size of this bunk silo. If he's got a couple of these, that's a large area in which we need to be collecting from. So we're able to design a system that we're getting the low flow, we're getting the important stuff, and the less important, more diluted stuff we are allowing to bypass. There's multiple ways you can do these low flow systems, and depending on your farmer, they might have a good idea on how to do it. Talk with your tech or your engineer and see if it's an option. This is another one where the flow is coming down here. Looks like on a low flow, it might trickle in beneath that tire, but in a high flow system, this will fill up. And once it starts to fill up, it can break over that there. So finally, some other considerations we need to address. Odor considerations.
And Anna,
what can we?
We're gonna
Yes.
need to we're gonna keep it moving. We're running behind, so if you don't mind
Yeah.
wrapping things up, that'd be great. Thank you.
Yeah, no problem. So we need to consider odor when we're looking at these facilities. We need to consider laws and regulations. Talk to your landowner, see if they know about anything that needs to be done there. Make sure they're talking to their local township. If they need permits, what do they need? And expansion and flexibility. And I'll just take a minute on this because I think this is really, really important. And it's not something that comes up all the time when we're talking to a farmer, but we need to be considering it. What does he want for the future of his farm? We don't want to be placing a system in a place that he's looking for expansion, or we don't want to be designing a system that's not going to fit him in 5 years. If he knows down the line that he's going to be expanding, we need to be considering that, and we need to be having a conversation with him about that. And routing of equipment, animal, stormwater. We need to be considering those things too when we're talking to him. We can kind of bypass that sometimes when we're talking about ag waste. We're so focused on ag waste, but he needs to be able to get equipment in there to either move animals or to move manure. And where's the stormwater going as well? If we don't consider these things, we could build the perfect manure storage, and it's just not going to work because the system around it won't work. And don't be afraid to talk to other consultants that may be involved in the project, like your ag extension engineer or your builders. What we said before, cost can play a big role in this, and unfortunately, we don't have a lot of information on what this is going to actually cost. So having a contractor come in and be able to give the farmer some advice on how this can, the cost of this it is really important because it plays a big role in it. Alternatives. Most sites have many different alternatives. It's our job to present them all to the farmer and let them make the decision. And like I said before, some can be eliminated right during the beginning discussion phase, but we need to make sure that we're giving them all to the farmer and letting the farmer decide what's going to work best for them. We can do cost estimates. equip incentive rates are not cost tables. That's really, really important. If we're giving out any type of incentive rate information to the farmer, this is not a cost. They need to go out and get prices from contractors and from different contractors in order to get actual installed costs. So reviewed the 9 steps in developing, reviewed the steps in developing an ag waste management system. We discussed some options that might exist. We reviewed the key elements of a ag waste management plan. And next week you will use what you have learned. So, alrighty. And thanks to everyone who had given me resources for this. So.
Thank you, Anna. Much appreciated. A lot of information. And I think a key take home point for me is that farms are different. There's a lot to consider, and we need to make sure that what we're putting in is going to work with that operation and how they operate and all the different things that they have as part of their operation. So thank you very much, Anna.
Yeah, no
really
problem.
appreciate the help.
Yep.
All right, we're going to move into our next presentation, our last presentation, which is economic labor time resources. So we're going to hear from Mary Lynn Marks, our Pennsylvania NRCS economist. So Mary Lynn, it is all yours.
Hello. Okay, let me get my presentation up here. Dun, dun, dun. Okay, let me see, presenting. Okay, can y'all see that?
Yep.
Oh, whoops, hold on. Okay, awesome. So thank you so much, Tim. Yes, my name is Mary Lynn Marks. I am the agricultural economist for Pennsylvania. And today I'm going to be introducing just some economic basics, really laying the groundwork for what we'll use these for next week in-person training. So I'll move through this real quick. I know we're at the end of the day. Thank you so much for letting me be here. I've been in the state office and within RCS for about a year, and I've really enjoyed it so far. But yeah, let's get into it. Oh, it's not gonna let me do it. There we go. Okay, so today's objectives, we'll go through a few things. One, learning economic concepts and their role in NRCS, as well as conservation planning. Identify how economic concepts can help us understand conservation impacts as costs and benefits. And relay economic information to landowner and decision makers to more effectively understand and consider a conservation plan. So really using economic concepts to kind of be in a certain mindset when we're talking to landowners, decision makers, producers, farmers, whoever it is, really about what we are doing for them and what we can do and kind of what the best option will be for them. So I know we've had a lot of jokes today, but my joke is I tell you an economics joke, but there's not enough demand. Man, he's killing me. So after that, hope you're all laughing. So can anybody say what is economics? I can't really see the chat. So, but anybody want to throw in the chat what they think it might be? See, it might be a way for me to see the chat. Okay.
No responses yet, but we might have warned people out, Mary Lynn.
Oh, well, that's okay. All right. Well, we'll keep rolling with it. So, so the economics are optimally allocating scarce resources for competing use. So a lot of people, I think they hear economics and they think money. And that's often true because that's how we kind of put our priorities in action. But it's really looking at the world around us as a bunch of resources that we have to decide how to use with the amount that we have, which is it's limited. So those can be inputs, labor, time, and land, especially in farming and conservation. But we really see this everywhere we are. You know, there's only 24 hours in a day. There's only 8 hours in a work day. You've decided to join us here in Boot Camp 2 training. And hopefully it's worth your time. Hopefully you're getting a lot out of it. But there's a lot of things that, you know, we can do with our time and with our resources. So really, just anything we can think of is affected by economics. So really those competing priorities and ensuring that we understand all of what those priorities are, what our resources are, and what our options are. So economics is used for information. So this is kind of a fun example, especially a real world example. So, you know, how people make decisions is really all around us. So here, you know, we can see Homer obviously loves donuts, but he's also very lazy. So if you put fruit in front of him, he's probably going to go for that because he values how lazy he is and not putting in any effort over his favorite food. So it's really all about what your priorities are, how you're going to make a decision. So it's all around us. And it's really just how we value resources and decision making. So economic priorities in agriculture, what might this look like? So really it's right now, like as a producer, you can ask yourself, could I invest in a large initial cost for future benefits? We just heard Anna talking about this with waste storage. And that was a great presentation, by the way, really loved it. But really just understanding, you know, can we even put in the cost up front and will the future benefits be worth it? You know, especially for something like a waste storage piece of, you know, a plan, as well as a piece of new equipment, maybe a tractor. Just keeping that in mind. For my next season, what crop will bring the most return based on current and expected market trends? We'll look at those in a second. And also work the best for my land. So, you know, there's a lot to consider when making those decisions. Do I have the time and or labor necessary for all operations? And do I need to prioritize some actions or resources over others? You know, maybe there's something I really need to get done this year, you know, maybe something really needs repairing, maybe something is something that I think could really pay off in the future. So I want to make it a priority over kind of my usual operations. So I thought this was really interesting, changing markets in the US. So this is corn prices received in the US over the last, like 10 years. So as you can see, you know, 2014 to 2020, about, you know, midway through, has been pretty stable, pretty low. And then going into 2021, we saw it absolutely skyrocket. There's a lot of things that go into that, market trends, market changes, but really high prices. And we saw a bit of a dip last year, but those are expected to go back up, I believe, and hopefully start to stabilize. We saw something really similar in soybeans. You know, again, we see this like kind of lower trend and then just absolutely shot up last year. And that's great for, you know, high yields as well as high returns. But especially when we're thinking about kind of operational realities, we also have to think about input prices on the flip side of that. So this is an index. So this is a bunch of products kind of rolled into one. But looking at chemicals, fertilizers, and fuels, you know, we saw something very similar, pretty stable, hit 21, and those also kind of went up because we all know, you know, we had a ton of supply chain issues. We had a major war in a very high producing area of the world. Mississippi River went dry for a second. So really just a lot of things that go into it. But the main point is that there's no way to know what the market's going to be on the price side or the cost side. So really making sure that we understand that that everything that we can put into a conservation plan and consider is important for the long run. So conservation, supply and demand. Price has to be, so supply and demand, we probably already have an idea of this, but price has to be low enough for consumers to want to buy, but high enough for producers to want to produce. Because if neither of them wants to interact, then there won't be any trade, there won't be any exchange of resources at all, and it just kind of falls apart from there. So where that meets is equilibrium. And that's, again, where our priorities are. So, you know, at the end of the day, the price, I'm never going to want to spend money, but if I think it's worth buying, I'll buy it. A producer is always going to want to charge more for their product, but if they, you know, if they want people to buy it, they're going to have to kind of go with the flow and price it where it needs to be. So what does this mean for conservation? That's a lot of fun words, but what does that mean? So while not traditional economics, it does still apply. Producers have to feel that the conservation that we are planning for them and that we are introducing to their operation is worth doing. And that is really what creates that demand. That's what makes them want to do business with us, wants to participate with us as an organization. Hold on a second. There we go. So again, want to create that demand. I really want to add value to their operation. You know, it might not be in yields, it might not be in, you know, direct price in the immediate future, but just to add value in general. So with an economic focus, economists love to say all models are wrong, but some are useful. And that's just to say that nothing that we bring them is likely going to be, except especially, you know, economics wise, is likely going to be exactly correct. We can bring them an estimate, we can bring them an idea of what we expect to happen when we implement the conservation. But there's no guarantees, especially, you know, in the market we just saw. So what we will analyze are those changes that we make. So ceteris paribus means with all else the same, also what we like to talk about in economics, which basically just means there's no point in looking at everything that happens on a farm if we're only going to be affecting a certain amount of the farm. So only focusing on the changes that we plan to implement. And again, considering conservation as an investment. So making sure that we come to them and say, you know, this is what we really think, you know, this is how we think we can improve your farm, your operation, the health of your soil, of your farm in general, et cetera. But really, this is an investment. This is something that might take time. And also coming to them and understanding, really important, that these are all estimates. When we put together, if we provide a kind of an understanding of what we think something might cost or what we might do, just that it is an estimate, really important. So conservation effects for decision making. I'm sure you've heard this again already, but you know, the benchmark condition is what we come in with. That's what's happening when we get there, the present condition. And then going to the conservation treatment, which is what we expect to happen with, you know, the future condition, what after we do the plan and after, you know, we kind of address resource concerns. But in between there are the impacts. Those are the things that we're going to change. And based on the decision makers' values, which we can address and we can maybe build on, we're going to assemble those into benefits and costs. And we kind of lay that out in a T-chart, which we'll work on next week. But again, this is really the ground layer for that. And so alternative effects can be kind of categorized in a few ways. So social effects are some things like a public good. So, you know, if you improve your stream health, that's going to impact more than just your farm. It can impact somebody else's farm, can impact something downstream, et cetera. As well as private social priorities. So we're not seeing it as much, but it's still definitely very prevalent for farming families to be kind of the main operators. So, you know, many people want to pass it down to their kids, or at least have the ability to pass the farm down to their kids, and to at least make sure that it's valuable once it reaches them. Kind of what we think is the economic monetary impacts, so yield impacts, input costs, as well as I think in the future we'll probably see some increased sustainability markets. You know, a lot of present consumers really like to see that their farmers are kind of considering the future and their environment and making sure that their operations are being as positively impactful as possible. So, you know, we're already seeing like the carbon market is ramping up, but I think we'll see more than that in the future as well. And then environmental, so this is really like our resource concerns. So, you know, erosion, runoff, wildlife habitat, soil health, the list goes on. These are really just some examples. So assessing conservation impacts a little further. We're going to use a benefit cost analysis, which estimates benefits and costs, converts those to like terms, and compares them. And we can do this on a bunch of different levels. And again, this is really in the T-chart. We'll be doing that next week. But to really use to organize and compare impacts across alternatives equally and effectively, and communicate those effects to producers for decision-making purposes. It really lays it out. It says, you know, this is this is good, this is bad, and are you okay with that? And, you know, are we okay with that, really? So pretty simple, benefits exceeding costs equals worth doing. So these don't always have to be monetary. They can be non-monetary as well. So a non-monetary impact might be reduced soil erosion and pollinator habitat. And a monetary might be increased profits. So, you know, either more revenue or lower input costs. So some examples of benefits. So these do include increased, this is income, but increased benefits as well as decreased costs. So these are some examples, you know, crop yield, land brought into production, wildlife fees, recreation sales, and then decreases in costs as well, you know, reduced passes over fields, machinery costs, fuel use, labor, fertilizer, agricultural chemicals, and irrigation costs. So really anything that is a benefit ultimately, whether it's a kind of a more of a good thing or less of a bad thing. Same thing with costs. So, you know, we can, for costs, you know, those can increase. So, you know, that initial installation costs, O&M costs, production costs, management, labor, any crop production risk there might be if that's affected, land use permits, or public health and safety costs. And then anything we take out of income. So land taken out, a change in land use, reduced crop harvest, shortened growing season, or foregone income. So anything that we could have done if we had kept that land in production. And again, I mean, this is just kind of some pictures of that. So installation, foregone, seed, fertilizer, operation, and maintenance. And kind of going off of that, our opportunity costs. So just kind of keeping us all aware, you know, every resource is used is a resource we can't use elsewhere. So really looking at alternatives, we can put together kind of a systems-based approach, but we can really only choose the alternative that's going to make the most sense for that farm. So, you know, we already kind of apply this in planning, but really thinking, you know, we can only have a certain crop in a field. We can only put our money in a certain amount of inputs, and there's only so many hours in a day. So realizing the cost of action as well as the cost of inaction. And then least cost analysis. So this is really helpful when not all conservation impacts are easily quantitative or monetary. So not everything is going to be, you know, we didn't do this, so we lost $20 an acre. Hopefully not that much, but really just looking at what would be kind of the most cost-effective alternative to address the resource concern. And the most expensive does not always mean the most effective. So I've got an example here. So which is least cost method? If we're installing a 1,000 feet foot terrace, so we can use tillage equipment for $3 a foot, dozer for $2.50 a foot, or a road grader for $2 a foot. And this is not accurate pricing. But I'll go ahead and say, obviously it's the road grader because it's the cheapest, but it'll still get the job done. And then further looking at economic awareness, just really making sure that we explain to producers, decision makers, farmers, whoever is the decision maker, that their project realities and responsibilities for installation, required management, actions and inputs, and maintenance, just so that they know fully kind of what they're getting into. And then looking at risk, you know, is it kind of a low level of risk, something that, you know, something might go wrong, but it's not going to have a huge impact regardless. Medium might affect some farm operations or cash flow, or high, you know, a significant loss of income or injury or damage to resources if things do go bad. And of course, this is all situationally dependent. So really kind of understand what's going on with your project and kind of what's going on that operation. Understand that conservation practice results are multiplied with a systems approach. There's been economic backing to support that. I know that's talked about throughout these trainings, but really keeping that in mind that it's likely going to work better if we do implement as many as possible that is applicable. And considering and making sure that we make the decision maker consider that short-term and long-term benefits are very different in conservation. And sometimes, as long as they know the realities of that and not, you know, if they expect, you know, if they expect something to get noticeably better within a year and it doesn't happen, you know, just making sure that they're aware that that doesn't necessarily always happen with every practice. And further on, economic and financial viability. So just because a practice is economically profitable, so eventually it'll pay off, does not mean that it is financially feasible for the producer. So that's really the difference between profitability and affordability. So making sure that we understand that, you know, expenses are a reality and that we can't just expect a producer to put up a lot of money up front if they can't, even if eventually it will pay off. And really communicating that effectively with the producer about whether it is financially viable for them. And I know this was already kind of mentioned earlier, but with the payment schedule, it is released annually. It's developed at the regional and state level. And I know Jared really emphasized this morning, but it is some supplemental partial assistance. So we are here, we are going to give them an incentive if we're using FA at all, but really that, you know, to make them understand that these are not cost estimates and they're, you know, welcome and encouraged to go get local vendor estimates themselves and see if that really stacks up with what we can give them, if that is going to be enough to make them want to do the project. Because payment schedule, the team really wants to emphasize that these are not cost estimates and we shouldn't lead with them. It's just what we can offer them. So that was a lot of information, but key points: identify cost analysis as estimates. The benefits are not guaranteed, but hopefully they are encouraged and we can help them out as much as possible. Consider potential conservation alternatives equally and effectively, and deliver conservation as an investment. It's something to work towards and hopefully achieve over a period of time. And communicate economic and affordability realities and make sure that you understand those as well. And really all this to just ensure sustainable and lasting conservation. Okay, so I flew through that kind of fast, but if y'all have any questions, please feel free to ask. Again, I would encourage y'all to maybe look at this and or bring it to the in-person training next Friday, because we're hopefully going to use some of this to create T-charts and do look at some other analysis that will hopefully be a little bit more helpful for in the field. But thank you very much for having me, and I will stop sharing. Okay.
Thank you, Mary Lynn. I appreciate it. And thank you to all the participants and the instructors that may be still on the line here. Just a reminder, agronomy will be meeting Monday at the NRCS State Office, and the engineering side will be meeting Monday at the Keystone Conference Center at the Fort Newtown Gap. If you have any questions about logistics, reach out to me, Tim Peters, or Shannon Winger from PACD. And we will look forward to seeing everybody next week. It's going to be a lot of fun. We're going to hit a lot of good topics, and we're gonna dive into infield sessions on some of the topics that we heard about today. So with that, that concludes our virtual session today. Sorry to get you out a couple minutes late, but thanks for sticking with us, and we will see you all next week.